We have a mine. The size of the pump to pump water out of the mine depends on how deep the mine is. Pumping out a mine that is d feet deep requires a pump that pumps a minimum of this formula. So I've got a formula. That's 150 feet, a mine that is 150 feet deep. That's what d is. Therefore, I just need to substitute in d squared over 25 plus 4d minus 250. It's important to make sure that d stands for what you think it does. Once again, though, let's be neat. Let's not start punching in numbers in the calculator. Write everything down. D is 150. Write it. Calculate it. This takes time, yes. Right answer, almost always. The length in inches of a box is 3 inches less than twice its width. I hate formulas or problems like this. However, if it says, suppose I have a box, draw a box with length and width. What's width? W. What's length? Well, it's 3 inches less than twice its width, so it's twice its width minus 3. I have a quadrilateral. PS and QR look parallel, and they are. For what value of x? Well, I'm tempted to say 112 because it looks like that's what the other opposing angle is, but there's no 112. Let's try something. If this were 90 and these were parallel, what would this x have to be? It would have to be 90. Therefore, using a simple example, kind of points me in the right direction. Since this is 70, what's x? Well, I'm tempted to say 70, but that doesn't look like it's 70. And then I realize that this is 70. And if that's 70, then x is 110. How many irrational numbers are there between 1 and 6? Let's draw a number line. 1 through 6. What can I put in there? Square root of 2, square root of 3, square root of 5, all sorts of numbers. Is it limited? I can put square root of 2. If square root of 2 is irrational, so is square root of 2 plus 1. Square root of 3 plus 1. Square root of 5 plus 1. Whoops. Therefore, there are really an infinite number of irrational numbers. High school student consumes 67.5 pounds of sugar, and they want to reduce sugar consumption by 20%. What's the maximum pounds of sugar to be consumed by each track team member in the coming year? Let's write things down to make sure we've got it clear. 67.5 times 0.2 is 13.5. But what does that number represent? It's how much I need to reduce my consumption. Therefore, I have 53.5 that I'll probably consume next year. 3 of the 4 vertices of a rectangle are shown. If this were a rectangle, what's the 4th vertex? Well, for goodness sakes, let's draw it. Many times that gives us the answer right away. And I see that the answer is 3, negative 7. However, if I wanted to actually calculate it, in the top, I go over 1, 2, 3, and down 2. In the bottom, I go over 3 then, 1, 2, 3, and down 2. And I see my answer, 3, negative 7. That's problem 7 through 12.